Welcome back to geometry. We'll be working on the last half of lesson 12.3b, more about area and trig formulas. In the last lesson that we did, we had two theorems. We had the SAS area theorem and the SSS area theorem, which is also known as Heron's formula. In the first one, we were finding the area of a triangle if we have an included angle in between two known side lengths. In the SSS area theorem, we were solving for the semi-perimeter and then substituting S into Heron's formula to solve for the area of a triangle that we had three known sides for. So SAS is used when you have two sides and an included angle. SSS is used when you have three side lengths, so be sure to have that in your notes. Let's look at example 3. There are two triangles to solve in example 3. Let's begin with the first one. And this is a triangle that has an included angle of 75 degrees. Right here, between two side lengths, one of which is 5 meters, the other is 4 meters. So we go ahead and use the formula. Area equals 1/2 A times B sine angle C. And I wanted to point out something here. This triangle has no designated angles. That means that any of the three formulas they gave you for this, and let me show them to you again. We had area equals either 1/2 BC sine A, or it equals 1/2 AC sine B, or 1/2 AB sine C. So you can use any of those formulas. They chose to use 1/2 AB sine C here, but actually it's technically sine 75 degrees. It really wouldn't matter because they have not designated any angles, what angle you put here. So we have 1/2 and the two known sides, so we had 5 meters times 4 meters, and then sine 75 degrees. In my calculator, I push 75, then sine times 20, and then times 0.5. And that gives me approximately 9.7 meters squared. Now the second half of example 3, we have a triangle that has three known side lengths, and we use the SSS area theorem. So the first thing we do is we find the semi-perimeter, and we use the formula for S, and S equals 10 plus 7 plus 9. So here they are in the triangle, 10 plus 7 plus 9, divided by 2 or multiplied by 1/2, either way, and our answer is 13. We now take the 13 and sub it into Heron's formula. And Heron's formula was side times side minus one of these sides times side minus the other side times the side length minus the third side. So this is first side, second side, third side, and we take the square root of that. So the 13 from the semi-perimeter, and you can see that it's inside all of the parentheses also, and then each side length, subtract each side length. So we subtract 10 and 7 and 9. We end up with the square root of 13 times 3 times 6 times 4, which equals 936. And I should actually have here the symbol square root of 936. Sorry about that. And square root of 936 equals 6 square root of 26 inches squared, which is about 30.6 inches squared. When we get into these large numbers, I have no problem with you leaving it as square root of 936 and then putting approximately 30.6 inches squared. If you're using your calculator, you'll be able to get to that easily. You do not have to go ahead and simplify here for a large number like this. That would not be an even number. So our homework is problems 13 through 17, extra credit problems 30 through 33, and number 37. So let me give you hints for each one of those. In homework problems 13 and 24, you're going to use example 2 to solve these problems. Example 2 in the book was using the right triangle ABC to prove tan x equal, oh, I'm sorry, wrong lesson. Let me get to the right lesson. So example 2 was find the square footage of a triangular lot with sides of 80 feet, 90, and so forth. And it was a triangle. It was not a right triangle. It was not an equilateral triangle, just a scaling triangle. It showed you the side lengths on all three sides, and it had one of the angles. In example 2, you dropped an altitude and then solved using your trig formulas to find the height. So you're going to be using that example 2 to solve for problems 13 and 14. Number 15. The altitude as a hint. Number 15 shows you an equilateral triangle where they've dropped an altitude and made two 30, 60, 90 triangles. So the altitude forms two smaller 30, 60, 90 triangles, and that tells us that the larger triangle is an equilateral triangle. And there's actually 3 different ways to solve this triangle. So you can use your formula for a regular polygon, or you can use the formula for the area of an equilateral triangle. And if you remember that, that's area equals square root of 3 over 4 square, side squared. Or you can use the semi-perimeter, and this is from example 3b, and then apply it to the formula for the area to solve. So whichever way you're more comfortable with. Of course, I prefer number 3 because that's what the lesson's all about, but it's up to you. Homework problems 16 and 17, solve like example 3b. Now, problems 30 and 33 are extra credit. They're very difficult problems. They will require that you make drawings and think a little bit outside of the box to solve. They're basically similar to example 1, but you'll also need to use some of the other examples to solve the unknowns to fit into example 1. To give you some incentive, each one of these problems is worth 10 points. And you can get partial credit if you make an attempt. If you decide to solve, I've given you the answers, but your answers must show work, and believe me, I will know if you use the answer key, so just don't go there. This is really important that you use this opportunity to show me what you've learned so far. And the last problem, problem 37, these are very basic. Use your calculators and double check with the table given out on Thursday if you so desire. And if you don't have your table anymore, you can see that on the internet, and it's just the trig ratio table. So that's what you can put in your search bar. So if you need any help, be sure to contact me. Otherwise, we'll be moving on to 12.5. We will not be doing vectors in 12.4.